We want to be able to relate our equations to balances, and whatever we can physically do to the balance, we can do algebraically to the equations. So here I'm going to use maybe squares and circles. So I've got 4x's, 2y's equals 18. So my balance is going to look like this. I've got my 4x's, and I've got my 2y's. And on this side, I'm going to have 18 ones. On this side here, I'm going to have 2x's, 2y's, and that's going to balance 10 ones on this side. So I can do a like for like replacement. Okay, so anytime I have a like for like, I can do replacement. Now, in this case, I'm going to do it differently algebraically, but in this case, I want you to make a note here because I have an equivalence here, an equivalence here, an equivalence here. So these are equal and these are the same. If I replace these, the two squares and two circles with 10, I've essentially eliminated my circles out of this balance, okay, which allows me to solve for this. Okay, so this is something that I can do whenever I have an equivalence. So I'm going to do something slightly differently here, in that it's essentially the same thing. We're going to isolate one of the variables and replace it. In this case, I'm not going to isolate the y. I'm going to do this. I'm going to take this equation. I'm going to subtract 2x from both sides. So I'm going to go minus 2x, minus 2x. I end up with 2y balancing 10 minus 2x. And since I have a 2y here, I'm going to replace that 2y with 10 minus 2x to get a new equation. And notice that my equation, I'm going to just number. This is equation 1 and equation 2. If I replace into the other equation, so this is generated from equation 2, and I substitute into equation 1, notice what I get. I get 4x plus, instead of 2y, I'm going to replace the 2y with an equivalent 10 minus 2x. Okay, so I just make sure that I've done like for like. By doing so, I've kept my equation balanced, but more importantly, I have eliminated the y variable out of this equation 1. I only have x's. So then I can go ahead and solve. Solving for x, I get 2x plus 10 equals 18, and that's what we would have ended up here if I replaced these four items here. I replace that with 10, right? So I would have ended up with 2x's plus 10 equals 18. Okay, so essentially done the same thing as I'd shown you earlier. At this point though, we can just solve this algebraically. We get 2x, subtract 10 from both sides, divide both sides by 2, and I end up with x equals 4. Once I've solved for that, I can plug it back into one of the equations and solve for the other variable. So I end up with 2y equals, this is going to be 10 minus 8. That gives me y equals 1. Okay, so those are my solutions. As an ordered pair, I can write this as 4 and 1. Again, we can draw a balance for this, so I'm going to end up with 2x's. So I'm going to have 2x's like this. Negative 6y's, I'm just going to show that as colored circles here. So there's negative 4, negative 5, negative 6y's, and that's going to balance 8 ones on this side. Here I'm going to have 1x, 4y's, and that's balancing 1y plus 10 ones. Okay, so there's my balance. It looks like in this case it might be easiest to isolate that x, so I'm going to call that equation 2, equation 1. So I'm going to take equation 2, I'm going to isolate one of the variables, so I'm going to subtract 4 y's from both sides. And then I'm going to do a replacement. Okay, so I'm going to take this equation and I'm going to replace that x. So in equation 1, and I have to substitute into the other equation. So if I use this one to isolate x, I need to substitute it into the other equation. So I'm going to end up with 2 times, instead of x, I'm going to use the equivalent negative 3y plus 10. And then minus 6y equals 8. So now I just have one variable to solve for. So I end up with negative 6y plus 20 minus 6y equals 8. I'm going to bring the negatives to this side, so it becomes positive 12y. Subtract 8 from both sides, I get equal to 12. Dividing by 12, I get y equals 1. Substituting into one of the equations, I can then solve for the x. This one it makes more sense because it's already equal to x, so it's just when I plug in y, I'm just going to do a calculation for x. I don't need to do any solving here. So I get negative 3 plus 10, so that's going to be positive 7 is my x. So x is 7, y is 1. Again, if I want to write that as an ordered pair, if I were to graph these two relationships, I'll get a solution at 7 and 1. And this is a good time to mention that you can always check your answers by graphing these equations. So if I'm not sure about my solution looks kind of funny, I'm going to go to my graphing tool, graph these two equations, and I'm going to check my intersection point.